The massive tower there, which again dates back right to the end of the last ice age, a huge megalithic tower with the world's oldest known megalithic stairway that runs up inside it. If Göbekli Tepe hadn't been found, none of this would have happened.
Long before cities were ever built and writing was invented, people moved great rocks. They put them in lines, circles, and many other places. Those stones sit where people came together, marked seasons, and held memories. Across deserts, hills, and islands, early builders left heavy marks.
There was a flood that covered every mountain on earth, and something fascinating is that in the Bible, in Genesis 8:20, some of the first verses after Noah emerged from the flood, is that he was said to have constructed an altar to the Lord.
But what if these stones weren't just monuments? What if they guarded a forgotten world that vanished before the Great Flood? The first hill, Göbekli Tepe. Göbekli Tepe sits on a low hill near the city of Şanlıurfa in southeastern Turkey. The place was first noticed in regional surveys in the 1960s, but its full importance became clear after the work of German archaeologist Klaus Schmidt during the same period. Schmidt led field seasons that showed the site holds stone rings carved long before towns and before large-scale farming. Radiocarbon dates place the main carved enclosures at about 9,600 to 8,200 BCE. The builders used limestone and shaped tall T-shaped pillars. Some pillars stand more than 5 meters high. Many pillars carry carvings of animals such as foxes, boars, snakes, and birds. Excavators label key rings in enclosures A, B, C, D, E, and F. Each ring contains upright pillars set on paved areas and bounded by wall stones. The pillars were cut from bedrock and moved short distances for final setting. Archaeologists record stone working marks and traces of tools. Hidden traces of fire, grinding stones, and food waste appear in the occupational layers around the enclosures. Some pillars show human features. The broad T-form reads like a torso. Several pillars include deep belt patterns and arms carved in low relief. Klaus Schmidt argued that the rings served ritual or assembly purposes at a time when many groups still relied on hunting and gathering. Later researchers refined that view as new evidence was found. Excavations recovered hearths and concentrations of animal bone that point to communal feasting at times. These remains allowed direct radiocarbon dating because organic material was sealed by deliberate filling episodes. Some rings show signs of intentional collapse or deliberate burial. Builders appear to have roofed some enclosures and then filled them with rubble and soil. Those fill layers preserved carved stone faces and organic fragments. Radiocarbon samples from the fill gave dates clustered in the early Holocene. The careful record-keeping by researchers made it possible to link art styles and construction choices to specific time ranges. After Klaus Schmidt died in 2014, archaeologists from the Şanlıurfa Museum and the German Archaeological Institute continued work. Field directors such as Lee Clare took part in later campaigns. In recent years, Turkish universities and national authorities joined the project under coordinated management. The site gained recognition on the World Heritage List in 2018, and work now balances excavation with conservation and visitor protection. Geophysical surveys and wider fieldwork show that Göbekli Tepe is one hill in a larger set of stone localities. Nearby, Karahan Tepe shares T-shaped pillars and animal carvings. Now, archaeologists and researchers use the phrase Taş Tepeler, the stone hills, to describe the region. Geophysical prospection suggests many more circular enclosures lie buried under the mound. Only a fraction of the entire mound has been opened by excavation. So much remains to be studied. In technical terms, the builders used simple machines and careful planning. They shaped blocks with flint and stone tools, carried pillars on rollers or sledges for short moves, and raised stones with ramps and wooden levers. The heavy blocks came from nearby limestone beds. Quarry traces and unfinished pillars show the step-by-step work of masons. The animal reliefs and repeated motifs match across several local sites. That shared imagery suggests networks of exchange and common ritual styles in the region. Field reports list many artifact types, including stone bowls, flaked tools, and grinding stones. Those discoveries occur together with food remains that show hunted species such as gazelle and wild sheep. The radiocarbon evidence is central to the site story. Charred seeds, bone collagen, and charcoal fragments from fill layers gave multiple dates that place the main construction in the 10th and 9th centuries millennia before the Common Era. Laboratory work used calibrated radiocarbon ranges to set the chronological frame. Archaeologists published the dates alongside excavation reports, so the timing and sequence stand on measured samples rather than on assumptions. The site shows ideas about closure and memory. Some enclosures were deliberately covered and left as a sealed deposit. That practice preserved materials for future records. People working at the site include field archaeologists, conservators, and specialists in zoo archaeology and radiocarbon dating. Publications and reports name institutions and leading researchers who provided the data and the chronological framework. If you visit the exposed areas today, you will see a mix of carved stone and careful excavation work. Conservation shelters protect the most fragile carvings. The open trenches, protective roofs, and visitor paths reflect a balance between research needs and public access. Work at Göbekli Tepe continues with surveys, limited excavation, and careful conservation aimed at securing the stone art and the data for future study. New surveys and careful lab work keep adding detail to the sequence, and small discoveries such as carved fragments, ground stone tools, and burnt plant remains help refine methods and dates. But could Göbekli Tepe be only one piece of a much older puzzle stretching deep into Africa's ancient sands? Sahara stones and Nile edges, Nabta Playa, and early African circles. Nabta Playa lies in the Nubian Desert in southern Egypt, near the modern border with Sudan. The place sits in a shallow basin that held water during the African humid period. The basin attracted people who moved across the desert with herds and seasonal camps. Fred Wendorf led major fieldwork at Nabta Playa in the late 1970s and 80s. Later researchers, such as Romuald Schild and J. McKim Malville, published studies on the stone settings and the burial features. Archaeologists identify a megalithic phase at Nabta Playa that stretches roughly from 4,500 to 3,600 BCE. Some stone placements and paired markers date earlier, around 4,800 to 4,500 BCE, when small circles and lines first appeared. The best-known arrangement is a stone circle and paired standing stones that some researchers call a calendar circle. The circle contains stones placed in pairs and groups that mark specific sight lines toward the horizon. Researchers recorded clay-lined tumuli and special graves with large cattle deposits. These cattle burials include ribs and skull fragments packed into clay pits and covered with small stone mounds. The presence of cattle bones and special burial treatment shows the importance of herds to the local groups. Archaeologists recovered pottery sherds, stone tools, and charcoal in the surrounding layers. Radiocarbon dating of charcoal and bone gave the time ranges used to frame the megalithic phase. Excavators used careful stratigraphy and mapping to record the layout of stones and the sequence of construction. In later years, researchers added GPS surveys, satellite imagery, and small test trenches to refine the map of the basin. These methods revealed alignments and patterns that survive in the sparse desert surface. Some people argue that the circle and paired stones mark the summer solstice or the rising of bright stars such as Sirius. Others point to possible lines oriented to the Orion Belt. A number of researchers caution that assigning accurate astronomical meaning is hard because the stones have moved and landscape reference points shift over long time spans. The discussion continues among specialists who note the limits of the data. Fred Wendorf and his team published detailed site reports that included pottery topology, radiocarbon measures, and descriptions of burial pits. The later work of Romuald Schild and of J. McKim Malville emphasized the possible calendar role and links to pastoral patterns. Other specialists used satellite surveys to locate more stone settings and to identify probable campsite scatters across the basin floor. The corpus of studies now includes field reports, lab dates, and mapped layouts. Excavators also found painted stones, small carved figures, and traces of plant processing and weaving near habitation areas with tools. The basin sits near a dry wadi called Wadi al-Mudawara. During the African humid period, rivers and lakes ran in places now dry. That wetter climate supported grass and water for herds. Seasonal lakes and marshes attracted people who moved herds and who met at shallow basins. Those meeting points show signs of repeated use, with hearths, pottery, stone tools, and the ritual deposits of cattle. The clay-lined tumuli are especially important. The builders dug pits, shaped clay linings, placed selected cattle parts inside, and sealed the pits with stones. Some tumuli included human burial with cattle offerings. The practice points to formal acts made by people who knew how to manage both animals and complex burial work. Research on Nabta Playa continues. Researchers use remote sensing, targeted excavation, and laboratory analysis to refine dates and to test alignment claims. Some studies reevaluate earlier claims about star alignments and propose alternative readings based on improved maps and more radiocarbon dates. The site's records of pottery styles, chipped stone types, and bone assemblages help place Nabta Playa in a network of early herding communities in Northeast Africa. In short, Nabta Playa provides named features and measured dates. The stone circle, the paired markers, the clay-lined tumuli, and the mapped scatter of camps offer direct evidence of people who used the basin across centuries in the 5th and 4th millennia BCE. Field reports and lab results from teams led by Fred Wendorf, Romuald Schild, and J. McKim Malville form the backbone of the published record on the site. But could Nabta Playa be just one piece of a vast prehistoric network connected by stars, stones, and forgotten rituals? Sea stone cities, Malta and Mediterranean temples. The islands of Malta and Gozo hold some of the earliest standing stone temples in the Mediterranean. The most famous site on Gozo is Gantija on the Jagra Plateau. Archaeologists date the main phases of Gantija from about 3,600 to 2,500 BCE. The complex includes 2 adjacent temple buildings and open forecourts. Builders set large limestone blocks in curved walls that form multi-apsed rooms. Some blocks weigh many tons and show smoothing marks from worked surfaces. The hypogeum of Hal Saflieni sits under the modern town of Paiola on Malta. Work at the hypogeum began in the early 20th century under Themistocles Zamet. The underground chambers date to roughly 3,300 to 3000 BCE. Workers cut halls and chambers from soft limestone to form a multi-level carved complex. Excavators found carved figures, red ochre on walls, and human bone deposits. The hypogeum served as a burial place over many generations. Tarxian, Hagar Chim, and Menajdra are other important temple complexes. Tarxian preserves spiral motifs and low-relief panels. Hagar Chim sits on a seaward ridge and gives wide views. Menajdra includes worked doorways and corbelled roofing in some chambers. Excavations at these places revealed pottery, stone tools, and small worked objects that help archaeologists trace phases. Early explorers and archaeologists recorded the temples before modern methods improved dating. Sir Temi Zammit and other early 20th century scholars documented chambers and recovered artifacts that later archaeologists studied. Later archaeologists used stratigraphic excavation, radiocarbon dating, and soil analysis to refine construction and use. Modern conservation uses laboratory work to stabilize carved surfaces and to conserve fragile pigments. The temple plan on Malta often uses an inward sequence of chambers that face a central court or passage. Builders arranged the stone rooms with a lobed design. The form repeats at several sites and shows an architectural tradition. Some walls display plaster that once covered limestone, and traces of pigment suggest parts of the stones were painted. Materials tell part of the story. Local Globigerina limestone provided workable blocks that masons cut with flint and stone tools. Obsidian and other non-local items appear in the finds. Obsidian likely arrived from Aegean sources such as the island of Milos. The presence of such materials points to long-distance exchange across sea routes in the Neolithic. The hypogeum shows a different style. Workers carved chambers below ground instead of raised stone rooms. The internal layout includes a central chamber that early excavators called the Holy of Holies. That space and adjoining rooms hold many bone deposits. Laboratory analysis of the bones shows repeated burial and reuse over centuries. The planning and the fine carving inside the hypogeum indicate skilled craftwork. Excavation reports indicate items such as clay bowls, small carved idols, and carved stone altars. Some figurines show pronounced female forms that early archaeologists called fat lady figures. Later researchers discuss these figures in more cautious terms. Conservation groups now limit access to the hypogeum to protect temperature and humidity-sensitive surfaces. Visitor numbers are controlled to preserve pigments and stone. The temple complexes received protection and study in the 20th century. The group of megalithic temples of Malta was added to the World Heritage List in 1980. Since then, archaeologists, conservators, and government agencies have worked to map, stabilize, and present the sites. Excavation and restoration reports name research institutions and national heritage authorities that manage the work. Field reports show that temple buildings on Malta included public stone architecture and private burial settings. Layers of pottery provide ceramic sequences that let researchers place tomb use into narrower time spans. Radiocarbon samples from charred seeds and bone added dates that align with ceramic chronologies. Recent studies examined acoustic properties inside the hypogeum and measured how sound behaves in chambers. Researchers published lab reports and site maps that refine chronology and dating methods. Today, researchers continue targeted excavation, laboratory study, and careful conservation to protect the stones for future research. The Maltese record shows a clear regional tradition. The architecture, carved motifs, and the range of finds show a community of builders who used local stone, traded for distant items, and maintained long-term care for special places. But could the hypogeum's mysterious acoustics and ancient craftsmanship share hidden links with other prehistoric monuments across the world, across Europe and beyond? Newgrange, Karnak, Menga, and global dolmens. Newgrange stands in County Meath in Ireland as part of the Brúna Bóinne complex. Michael J. O'Kelly led important excavation and reconstruction work in the 20th century. Radiocarbon dating places Newgrange at about 3,200 BCE. The mound is a passage tomb with a 19-meter-long passage and a cruciform chamber. Each year at the winter solstice, a shaft of light passes through a small opening called a roof box and lights the inner chamber. That accurate alignment shows careful planning and careful stonework. The Carnac stones in Brittany, France, include thousands of standing stones set in long rows, in dolmens and in burial mounds. Many of the stones date between about 4,500 and 3,300 BCE. The alignment at Les Menecs is among the best known. The scale of the Carnac landscape is exceptional. Researchers have debated the meaning of the rows. Some see procession routes. Others note burial and territorial markers. The stones, however, stand as a record of long occupation and repeated rituals along the Breton coast. In southern Spain, the Dolmen of Menga near Antequera is a massive gallery tomb dated to around 3,800 to 3,600 BCE. Modern studies show capstones and wallstones that weigh many tons. Recent geoarchaeological work described how builders tilted and supported the side stones so the heavy roof stones could rest safely on top. The scale of Menga shows sophisticated local engineering in the Neolithic of Iberia. Stonehenge in Wiltshire, England, was built in many stages from about 3,100 to 1,600 BCE. Its early phases include a circular ditch and timber posts. Later, the great sarsen stones and the blue stones were set in place between about 2,600 and 2,400 BCE. Stonehenge shows long-term reworking and reuse. The stones came from both local and distant sources, and the site played many different social roles over centuries. Beyond Europe, large numbers of dolmens and megalithic graves appear across Asia. Hirebinakal in Karnataka, India, contains hundreds of megalithic burial monuments. Many of the Hirebinakal monuments date to the first millennium BCE and to the transition between the Neolithic and Iron Ages. Local reports and recent surveys show carved rock art, cup marks, and a large kettle drum stone that makes a resonant sound when struck. Hirebinakal is on India's tentative list for World Heritage. Korea has tens of thousands of dolmens. The Gochang, Hwasun, and Ganghwa dolmen sites are registered by the United Nations Educational, Scientific, and Cultural Organization. Most Korean dolmens date to the first millennium BCE and to the Bronze Age. Excavations at these sites produced pottery, metal objects, and grave goods that show a society with elites who marked status with stone tombs. The dolmens vary in size and style across the peninsula. Japan also has regional dolmen fields and megalithic features. Japanese megaliths often appear as simple stone chambers or as markers near burial sites. In each region, the stones and the burial practices carry local meanings tied to ancestors and social rank. Across these places, the common theme is local practice. Each region used stone differently. Newgrange uses careful light alignment and carved curbstones. Carnac arranges long rows and large landscapes. Menga shows huge capstones and complex support. Stonehenge combines local earthwork and distant stone. Hirebinakal, Korean, and Japanese megaliths show regional funerary practices. Each example offers a distinct way that stone held memory and social order. Each site reveals human skill. Comparing these sites shows that people in separate places and at different times chose stone for lasting monuments. The reasons vary. In some cases, stone marked burial and ancestors. In other cases, Stone marked seasonal signs. In still other places, stone created visible signs of power. The variation matters because it warns against a simple, single explanation. Stone buildings appear around the world as a human response to local needs, local stones, and local social choices. From Göbekli Tepe to Stonehenge, humanity's earliest builders left clues carved in stone, traces of knowledge lost to time. Were these monuments mere rituals of survival or remnants of a civilization that thrived before the Great Flood? Each new discovery draws us closer to an unsettling truth. Our history may be far older and far stranger than we ever imagined. We have come to the end of our video. Don't forget to share your thoughts with us in the comment section below. Thank you for watching.